play a quick game, because why not, right? I'll shout out names of a few programming languages, and if you like that language, if you're familiar with it, say I, right? For example, Ruby, I. All right. JavaScript, very nice. ASCII dots. How about Haskell? I. Okay. All right. Elixir. All right. Prolog. Go. Ah, a lot of Go people here. SQL. Hi. Well, speaking about SQL, let's hear from Hari, who is here to talk about databases. He's from Kerala. He runs a company called Red Panthers, and he drinks whiskey. Over to you, Hari.
Okay, you guys can hear me, right? Adding to the list of languages, Crystal. Anyone doing Crystal? Hey, one guy. So I guess we are all Rails developers or Ruby developers in the room. And without any doubt, we all have touched database some way or the other, right? We always used it. It's been there. In any application, it's like a black box. It's there. It's running. We know it's there. But half the time, we have no idea. So my talk is going to be about how I used the database that was always there to scale my application. So this is me. I'm known as CodeRedchus in the web. Everywhere I'm CodeRedchus, and if you find somewhere there I can register the username CodeRedchus, let me know so that I can register there as well. And I write Ruby code for a living. I have no other job, seriously. And I love stickers. I'm competing with Prathamesh to be the guy with the most number of stickers. So if you have some stickers, please think of me. And I have stickers as well. I have Red Panther stickers with me, so just meet me after the talk. And this is my company, which I co-founded. We do Rails exclusively, and we're based in Kochi, Kerala. How many of you guys have been to Kerala? Oh. So we had 2 RubyConf India there, and I'm planning to build another conference there. It's a beautiful coastal city, and if you guys are planning to come down there for a vacation and need a place to work or just hang out or some people to go get some beer with, just tweet out to us. Oh, yeah, this will be useful. So let me tell a story. Doesn't work. Of a novice developer who wrote the first lines of code of a web application that's meant to process just 1,000 rows maximum and 10 users. That's what I was told. And it grew so big that we were processing like a gigabyte of data every hour. And that was me. So this talk is all about all that things that I learned, which helped me scale the application without investing a fortune on hardware. No, works right. Okay. Oops. Wrong presentation. Okay, sorry. My presentation got switched. Okay, sorry about that. Few technical difficulties, and of course, we are all programmers here, so we know how it happens. So let's start. So I'm going to talk about the tools that I use. And in my universe, they're known as Avengers. where Ruby is Captain America, Rails is Iron Man, this guy can do anything, and my database is the Hulk. Hulk can smash. But the problem is, like, we use the Hulk to carry our suitcase. We use when he could literally do anything that we want. So I'm going to talk about, we are going to offload everything to the Hulk. We have a Hulk, so do not feel scared to use it. So I'm going to, just the technical terms here, I'm going to talk about query planner, indexing, attribute preloading, materialized views, generating JSON APIs from the database itself, and synchronous commits. So starting with the query planner, database is a general purpose software, right? But we don't build software for general purpose. Every software that we write is for a domain or a special purpose. But the tools that we use are not built like that. It's not built for a single use case or industry. PostgreSQL is built in such a way that anyone can use it. So how does it handle all the scenarios? The truth is it doesn't. Our database is not meant built just for web apps. They're meant for a lot of various purposes. And the DB doesn't know all the scenarios that it's put under. So we need to nudge it. We need to change it. And there, the more important thing is that the SQL syntax is all about how the data should be. When we do user dot first and we get the element, the SQL query that runs underneath it selects all the attributes, selects star from users, where we are actually saying how my data should be or what the data I should get. But we are not telling it how to get the data. We as programmers, we write algorithms, we write code so that we can improve stuff. And we're using a database. Literally, we have no idea how it's getting the data. I'm sure that everyone who's gone to college have learned about binary search, sorting, all those things. And what is the algorithms that the database is using? When we write a Ruby code, we control that. But in database, they don't. And all database has something called a query planner, and that's what decides how it's going to get the data. It's the brain of your database. So we need to understand how it works so that we can manipulate it. The query plan is created by the DB even before we execute. So when I say select a couple of attributes, the database creates a plan based on which it takes the decisions. It does a cost analysis. It's like all those AI systems that you see on all the TV, all the programs. See all these simulations. It runs in his mind, multiple simulations, and finds the best. And the problem here is, once it makes a decision, it assumes that it's the best decision. But in some cases, it's not. So we need to change it. So how do we see these plans? In Active Record Rails, we have a method called .explain, which displays this plan to us. So if you look here, I just search for my user with ID 1. The first one, you can see the cost is 8.17. It's like in milliseconds. The lower one, it's 18.12. So that means it is the maximum time it could take. I mean, it will go to the entire database. It will take this much time. And as the number of rows increase, the cost increases. So we should see that cost. So we can check this plan to find where our system is slowing down. If you see that your database queries are taking like 5 minutes, has anyone seen that? Because I've seen that. There are queries that keeps on running for hours, actually. And we should know where we are losing time. Because without knowing where we're losing time, we can't fix it. And we look at this plan and make the decision. And now I'm going to start talking about my real stuff, how to do this. And please feel free to use this, because I've done all of this in production, and we are still live. And a tip, if you are trying to get the, we can get the plan in various formats. So how to do that? Indexing. Let's index everything. Let's not do that. So index is like a special lookup table. So we have 1,000 rows in your database, so in the table, and you're trying to find something. And the simplest thing is actually go through all the 1,000 until you find it. Indexing improves it a lot. So if you just see in this plan, you can easily identify the one with index and one without the index. The one with index takes less time. And it's like another table inside your database that has all your data alphabetically sorted. And you know something? Databases are smart. Well, really smart people build it, and it's like really older. And even if you have an index, your database will ignore it. Why? Because when it ran the plan, it found that going through the index was taking more time than a sequential search. And the database will still use it. So even if you have index, database will ignore it. An example, let's say you have 10,000 rows in which you only have 3 values, which is short, medium, and long. And the database is looking at the plan and saying, dude, I will just sequentially search it, and it gives me more, it gets me the data faster. So it will do it. So what all should we index? We should index the primary key, we should index the foreign key. If you have something that you're putting into where, you need to index it. The joins. You can join tables with other than the ID, by the way. And date columns. Anything that you're actually planning to do in your report, do index it. And also you can add something like a partial index to scopes. Anyone using Rails, I'm sure that you have used scopes. You can do partial indexing there as well. But do not index the tables which has lots of read and write. Do not index table that you know that will always be small, and do not index columns where you will be manipulating a lot of its values. Because every time you add a value, it takes an extra effort to create the index. Now, we lose time in the inserts, but we make up it when we read. So if you're planning to read a lot, then index. Next is attribute preloading. I'm sure that everyone here knows the n+1 query. Anyone who has attended an interview, that's the first question. Do you know what an n+1 query problem is? So we are going to use Postgres to do that. Now, this is the Rails way. And the thing about the Rails way, it's good. We do 2 queries to find all the tasks and include the tags. This is the query that gets generated. It's run in one shot, and we get objects for each task. So let's say there's 1,000 tasks, then I get 1,000 objects. Of course, it won't be loaded until you access it, but still. But using Postgres, I found that I can still get the objects, and I can do this in one SQL query, and it's 3 times faster. Now, it's important to note that the size of the table matters. So if you just have like 1,000, as I said, 1,000 rows, and you think about this kind of optimization, you feel like it's a joke. There's not much difference. But I'm talking about tables which has like 8 to, last time I checked, it was 12 gigabytes. So when you're trying to load 12 gigabytes to memory, then yes, it's better to do this. The next thing that I did is called materialized views. So what are database views? Before I talk about materialized views, I need to talk about what database views. And anyone, of course, all the Rails developers knows MVC, and everyone knows what a view is. And the thing is, there is something called views in database, which is the same concept as our Rails views. we get data from multiple places and display it on our HTML page. So we can do the same thing inside the database, where you have multiple tables. Let's say you have a report that's joining like 10, 20 tables. We can make them all into a single view so that your code is much cleaner. Every time you're just accessing that single view. And why would you do that? Because it makes life easier, right? So let's say if you want managers, all the managers in the company, you run that and you get the query, right? That's 3 lines. Really bad example, but if you make a view out of it, then you just need to access it by just access it same as your SQL table, but to the view. Now, it's to be noted that this view, and when you say database view, it's not a real table. It's like a schema that lives in the memory of the database. The result is not stored, and it's actually running out query to get the results. Now, the only advantage, the performance advantage you see here is that, as I told you, whenever a query is run, a plan needs to be run. It should create the plan. We can avoid that if it's a view. Why? Because it already planned it out, right? And there's another thing. As you know that what we are writing is just text, one single line of string. This text gets converted to a tree inside the database. And the thing is, Active Records also does the same thing. Active Records also creates a tree structure so that it can build this query. So when you do like one after the other, Active Record doesn't execute everything together. It just adds stuff to the tree. And we have something in the database that does that. So all the SQL that we write is for humans, not for the database. So the database still needs a tree. And if you use the view, it has already built that tree. So it saves some time there. And they're called pseudo tables. Now the materialized view here is that it will actually store all the content to a temporary table. That's the advantage here. So every time you refresh a web page, right, instead of running the query again and again to get the results, we can store them all into a table. And this table doesn't make sense to us because it's not actually a part of a program. But if we create the view, it creates this pseudo table which we can refresh. It was first introduced by Oracle, now found in PostgreSQL, Microsoft, everywhere. MySQL, when I last checked, it still doesn't support it, but there are open source extensions that lets you do that. Now, how can you? So I've been talking about database a lot, and I'm really thankful for you guys for not making a scene here because I came to a Ruby conference and was talking all about databases. So now let's talk about how we're going to use it Ruby. Yes, we still have to write SQL. I'm so sorry. So you write a migration that creates this. And you can access it as an object. The only thing, you have to declare the table name as the new materialized view name. And it's a read-only table. It's not real time. Every time it runs the query, it updates it, so you refresh it. It's really useful for sales data, in which, like, I have a history of sales, and I need a report. And only real-time data is now, well, everything in the past is history, in which we have, if you run this, all the data is always there. And also, we can use everything. Everything that SQL provides, we can do it. We can select, we can search, we can find the first, last, everything. And we can index it as well, by the way. We can index a materialized view as well. And that's a real use case in which 976 milliseconds came down to 2.3 milliseconds. And my client was happy, my client's users were happy, I was happy. Now, it's faster to fetch data. It's capture commonly used joins. It pushes a lot of tasks that we are supposed to do in Ruby to the database. Because I was supposed to get all this data from the database and then generate the report. Now it's nothing but another table. I can just pass it on to data tables to take care of the rest. But it will use up more RAM and storage, yes. And you can't have live data. That is a problem. But you can, as programmers, we can find a workaround. We can build a system such that it will have live data. It joins two tables, and we can do that. Now, this is the most important thing that really saved my life. If there's one thing that you guys learned from my talk, I would say it's this. We offloaded the entire JSON generation to the database. Our APIs were getting the response from the database directly. Because websites are simple HTML and plain JavaScript. And as you know that with Angular, React, everyone and lots of single-page applications are coming. So the importance of JSON is increasing. So if we can get the data source to be in JSON itself, it makes a hell lot of a difference. Now, Postgres has these methods that lets you convert an entire row to uses, in which instead of getting the data in the SQL format, I got it as JSON itself. Now, that's not practical. I'm not going to send my entire user table to the users, right? It doesn't make sense, because I'll be crazy to do that. Which means we need more practical queries. We need to be able to select stuff. So PostgreSQL does that. It lets you select something and then convert it to a JSON. So if you think back, if we have the materialized view, which is for the report. I can convert that view to a JSON, which means my entire API is now coming from the database. And we can have complex stuff as well. And also, we did data preloading. So all the things that we did before, we send it to the user as JSON in the end. And also, we can build stuff that's not even related to the database, right? We can generate JSON who doesn't have anything in the table. So that's also done. So we can build objects. Again, yes, where is Ruby? So there are really a lot of gems that let you do that. This gem that I use, which help us get the data as JSON itself. Underneath the hood, all these queries run, which we don't want to know. And we can still get this. But for more complicated stuff, we still need to end up writing SQL. Ruby has been here for 20 years, and still it's going to be there for more. And SQL has also been there for even longer than that. So it's matured, and it has a lot of things. So we should learn them. But like me, if you want to keep as much stuff as possible Ruby, then create a materialized view and just generate the JSON from it. So in the benchmarks, I was having my APIs, which was taking 2 seconds, which is a really long time in the API world, came down to less than 200 milliseconds. So some of the benchmarks that I found is that we increased 25 requests per second to 467 requests per second using this SIF. And the final thing is the synchronous commit. So when we use a database which is really smart, takes care of failure. As you know, software, the designers takes lots of design decisions. Some people prefer performance over productivity. Some people prefer productivity over performance. Some people prefer reliability. So most of our database is meant to be reliable, because from the early days itself, the database was first pioneered by financial applications. You can't have data failure in a bank, okay? Which means if I deposit 1,000 rupees, then it's gone. If the database fails, then I just lost my 1,000 rupees. So it waits. So even if you insert something let's say, 1,000 queries at the same time, it runs them one after the other. It makes sure that it's written to the hard disk, it's logged properly, and then says, okay, give me the next query. But in a web application, sometimes we can't. We need faster responses. So we need to make them run concurrently. So there's something called the synchronous commit, and which lets us do that. So we can turn it off in a database. inside our transaction, per that transaction, right? So if I'm trying to insert 1,000 users, let's say if you're importing a CSV file, and you're fine with importing, then turn off the synchronous commit, it speeds up your write. But of course, the problem there is that if the DB crashes in between, then your data is gone. But the advantage is that if you know that you don't mind losing some data, then it's good. For example, like we work with a lot of RFID readers sending us a lot of data. We don't mind if we lose a couple of bits, but we do mind if it goes down. So in which cases we are fine with enabling this, turning off the synchronous commit, because we just wanted the data to enter our system as soon as possible. I'll just share the slides after this. This is some of the configurations that I use. So with the Postgres, we can configure it. So there is, and I placed it in my Rails application itself. That's why you find a lot of ERB syntax, because I wanted to control it. I wanted to see how we can change it and tweak it in future. I don't want to like deploy the server every time. So we can keep it in our Rails application itself. To summarize, index data so that we don't end up scanning the entire DB. Use arrays for data preloading. Simplify the view using JSON. Move more complicated stuff, more complicated JSON generation to the database. Essentially, you're moving your serialization, the serializer that you have in Rails, to the database itself. And disable synchronous commit if you know that it's not going to harm you. So the conclusion that I like to say is that know your tech stack. A client came and told me that this application that I built is really good. He wants to sell it to a lot of people. And I said, yeah, that's really good. No, you can sell it. And then he told me that let's move it to the cloud. And the funny thing is, he actually set up the AWS, had the application installed there, and then we started fixing it. So that's when I said that I built it for 1,000 rows, and in the end, it moved to the cloud. It was supposed to be for one store. Now it's 40,000 stores. So as the data increases, it was creating more issues. So that's when I started looking into the stack, because cost was a factor. We couldn't increase the billing per store. So we learned. I learned more about the tech stack. I found the database. I found that there are a lot of moving parts in our application. You take any project, there are a lot of moving parts, and we should have full control over it. So as a programmer, it's our duty. And SQL has been around for like 40 years, and it's still going to be there. I know that when I started in Rails, I was from the PHP world, by the way, and like most people here. When I saw that I could do user.findID1, that's it. I decided to go for Rails. I never looked back. It was the perfect thing for me. But as the complexity grew, I still went back to SQL, because yes, it's going to be there. I know that we still love Ruby, but yes, we still have to learn it. And there is no golden rule when it comes to performance optimization or the best things. Like, it's all opinions. So what worked for me might not work for you. So do tweak around and find what's good. I blogged about all this in my blog. You can find and read more details on how I did every single one of them. And that's it. I blog about Postgres and Ruby on Rails at our company blog. A small promotion.
All right, round of applause for Hari. Thank you, Hari.